Light is our primary source of information about the universe. We can only detect objects and events that are within a certain distance from us. This limitation shapes the boundaries of what we call the observable universe. Consequently, we are unable to directly observe occurrences or celestial bodies that took place or formed very early in the universe's history, billions of years ago. While we can hypothesize and infer from existing data, we remain physically constrained by the finite speed of light. Light must travel from its source to reach our observation tools on Earth or in orbit. If that distance is too great, the light hasn't yet reached us, and perhaps never will. This cosmic barrier naturally raises questions about the completeness of our understanding and whether something vastly important lies just beyond our perceptual limits. Currently, scientists estimate that the diameter of the observable universe is approximately 93 billion light-years. This measurement is surprisingly vast when compared to the estimated age of the universe, which is about 13.8 billion years. The immediate reaction one might have is confusion. How can we observe something that is larger in distance than the age of the universe seems to permit? The reason for this apparent discrepancy lies in the continuous expansion of the universe over time. Space itself has been stretching, growing, evolving since the Big Bang. Galaxies and other objects are not just traveling through space. The space between them is expanding. Cosmic expansion has caused objects that were once relatively close together to move increasingly farther apart. It's not simply that galaxies are flying away from us, but rather that the fabric of space itself is expanding, like a balloon being inflated. As a result, the light emitted from these objects has taken longer to reach us. What we see now may have been emitted billions of years ago from a source that was much closer at the time. Over time, that source has moved farther away due to the stretching of space. This makes the universe appear much larger than its age might suggest. What we perceive is not a direct image of current conditions, but a kind of time capsule, light from an ancient past traveling across an expanding canvas. The universe remains an enormous and captivating expanse, filled with countless mysteries yet to be uncovered. Despite the limitations of our observations, each discovery adds a new piece to the vast cosmic puzzle. Thanks to advanced technology like NASA's James Webb Space Telescope, JWST, and other instruments, scientists continue to uncover new insights into the structure, composition, and history of the universe. These tools allow researchers to see deeper into space and further back in time than ever before. Each observation from such powerful instruments reveals another chapter in the cosmic story, one that helps us understand our place in the grand scale of existence. These tools also help investigate various cosmic phenomena that continue to puzzle and fascinate both scientists and the public alike. Join us as we explore an immense cosmic structure recently detected by one of these telescopes at the far edges of the known universe. It's not just about distance, but about time, scale, and the unfolding complexity of what the universe was, is, and might become. If you're interested in staying updated on such discoveries, consider subscribing to our channel, liking this video, and turning on notifications. Our journey through the cosmos is far from over, and every new revelation adds depth to the awe-inspiring story of our universe. One of the most intriguing questions in cosmology is what lies beyond the observable universe. This question taps into the deepest corners of human curiosity. To reach those farthest cosmic frontiers, humanity would need to develop transportation methods that transcend space and time. Current physics suggests limits. Nothing can travel faster than light, but that hasn't stopped theorists and dreamers alike. Concepts like distortion engines or wormholes have been proposed as possible solutions. These ideas are more than science fiction. They exist within the theoretical frameworks of modern physics and relativity. These ideas have been hotly debated in scientific circles. Some experts argue that such travel contradicts the principle that nothing can move faster than light, thus violating a fundamental law of the universe. However, others believe that advanced technologies might eventually make it possible. They point to gaps in our current understanding of quantum mechanics and gravity, suggesting that future insights could rewrite what we consider impossible. The feasibility of faster-than-light travel and the development of technology beyond current human capabilities is still highly speculative. Yet, speculation is often the first step toward discovery. Even if theoretically possible, achieving such advancements would require machinery far more advanced than anything we can presently construct. The scale and energy requirements would be astronomical. According to the theory of cosmic inflation, the entire universe might be at least 10 squared cube times larger than the observable universe, a scale so vast it defies human comprehension. The observable universe is merely the tip of the iceberg, the lit portion of a boundless, shadowed realm. Since we cannot see or measure what lies beyond the observable boundaries, we cannot confirm what exists outside. Nevertheless, by analyzing data from observable galaxies, scientists can develop theoretical models. These models allow us to simulate and predict conditions in regions we cannot directly observe. And NASA plays a crucial role in that process. In collaboration with global space agencies and research institutions, NASA has made substantial contributions to our understanding of the universe. Their missions, telescopes, and dedicated teams have pushed the boundaries of what is known and imagined. Even before the James Webb Telescope became operational, NASA released images of the ultra-deep field captured by the Hubble Space Telescope, a breathtaking collection of some of the most distant and ancient galaxies ever recorded. When JWST launched and began observing, it focused on capturing images of the most distant galaxies ever detected. These observations unveiled countless galaxies shining in the ancient cosmos, appearing as they were millions of years after the Big Bang, about 13.8 billion years ago. Due to the universe's expansion, the light from these galaxies has been stretched to redder wavelengths, a phenomenon that enables JWST to detect them in the infrared spectrum. This redshift is crucial. It lets us see things the human eye cannot, capturing traces of energy from the universe's earliest moments. This capability allows scientists to observe galaxies forming in the universe's early developmental stages. The James Webb Telescope has observed various fields filled with distant galaxies, enabling researchers to study how quickly stars formed in the early universe. These observations have revealed a significant population of galaxies that were actively creating stars during that primordial era. The findings reshape our understanding of galactic evolution, indicating that stars and planetary systems may have formed much earlier than previously believed. These discoveries are not only fascinating but also provoke deep philosophical questions. For centuries, humanity has wondered whether we are alone in the cosmos. Are we a unique accident, or just one of countless intelligent species scattered across space and time? The growing number of detected galaxies within the observable universe suggests that countless more may exist beyond it, an idea that is both astonishing and humbling. The vastness implies possibility, and that possibility raises the ultimate question: are there extraterrestrial beings elsewhere in the universe? The possibility of life beyond Earth has become increasingly compelling. Numerous planets beyond our solar system, called exoplanets, have been discovered using methods like the transit method and the radial velocity method. These detection methods analyze slight dimmings in starlight or gravitational wobbles to identify planets orbiting distant stars. Some of these exoplanets possess characteristics similar to Earth's and may potentially harbor life. This theory gained further support thanks to the James Webb Telescope's observations of the exoplanet WSP-96b, located outside our solar system. This planet's light spectrum revealed the presence of water molecules, an extraordinary finding. Water, essential for life as we know it, dramatically increases the planet's potential habitability. Additionally, the spectrum showed indications of haze and clouds, features previously thought unlikely on a potentially habitable planet. These surprising atmospheric features hint at complex weather systems and chemical processes occurring on distant worlds. Considering these discoveries and the existence of habitable environments beyond Earth, it becomes increasingly difficult to dismiss the possibility that intelligent life may exist elsewhere in the universe. While we have yet to obtain definitive proof, accumulating evidence suggests that extraterrestrial life remains a viable and enthralling possibility. The more we learn, the more the odds seem to shift away from Earth being an anomaly. Now, let's delve into the concept of the multiverse in the context of the observable universe. The idea of a multiverse, also known as the many worlds interpretation, is a theoretical concept in both physics and philosophy. It proposes that multiple parallel universes or dimensions exist beyond our own. This hypothesis offers radical new ways to interpret reality and existence. The multiverse is often discussed in relation to quantum physics, which studies the behavior of subatomic particles. According to some interpretations, merely observing a quantum system can cause it to collapse into a single state. In contrast, the many worlds interpretation suggests that observation causes the system to split into multiple realities, each representing a different outcome. In this view, every decision, every quantum event, spawns a new universe where an alternate result unfolds. It's a profound, almost dizzying notion that we live not in the universe, but in a universe, one among an infinite array. It's important to acknowledge that the multiverse remains a highly speculative idea, currently unsupported by conclusive empirical evidence. As such, we cannot definitively determine whether it is a valid theory. Nonetheless, Some scientists and philosophers find the multiverse concept intriguing and potentially helpful in explaining otherwise puzzling phenomena. Others remain skeptical, questioning the theory's scientific legitimacy. Given that we cannot yet determine what exists outside our universe, the multiverse remains a possibility, much like Schrödinger's cat or the enigmatic nature of dark matter. It's a concept that inspires both fascination and philosophical contemplation. Though further research and evidence are necessary for